Good evening, students.
Good evening,
Good
sir.
evening, sir.
Good evening,
Good
beta.
evening.
Good evening. So today we are going to start rotational dynamics. Rotational dynamics. In rotational dynamics, first I am going to start with moment of inertia. Moment of inertia. Moment of inertia. So basically in moment of inertia, there are two parts. First, I'm going to discuss moment of inertia, and later on we will expand it to moment of inertia tensor. So first, we are going to start here. Now, if you remember, if you are having a block and you place this block on a surface, now suppose it is at rest, and if you want to change its state, it is at rest now, right now, this is M, mass M, and you want to change its state from rest to motion. What you are going to do, you have to apply a force. So what you will do, you are going to apply a force, and as a result of this application of force, this state of rest, it may convert into a state of motion. So basically, when you are applying a force, there will be some resultant momentum and it will start moving. So basically, state of change we are changing here by the application of the force. But how much force is required so that it starts moving, that depends upon the mass. Higher the mass, higher will be the force required, ठीक है ना, so that it can change its state of motion. It can change its state from rest to motion. So here, this mass m, it is acting as a property of inertia. It is representing inertia. Inertia. So higher the mass, you will require more force so that it starts moving. It starts moving. So here, in case of translational motion, basically mass of an object is acting as the property of the inertia. Very similar type of property is there in the rotational motion. If some object is at rest or it is undergoing uniform rotation and you want to change its state, suppose from rest, you want to move it, you want that it should undergo some rotational motion, and if it is undergoing some type of rotational motion, you want to bring it to the rest. You want to change its state during rotation. Then the property that is acting as inertia, ठीक है ना, that is called as moment of inertia here. So moment of inertia is the property that opposes the change in the state of the object which is undergoing rotation about an axis. So if an object is, suppose this is axis of rotation and you are having a particle m here, and it is undergoing this type of rotation about this axis. This particle is going like this, it is rotating like this. Then the property, ठीक है ना, that opposes the change in its state of rotation, that is called as moment of inertia. Moment of inertia. What will be the moment of inertia of this? This will be m. Mass is m. This mass is m. Now, what is the distance of perpendicular distance of this mass from this axis of rotation? Suppose that is r. So moment of inertia of this object that is rotating about an axis, that will be given by mr square. So mr square or moment of inertia is the property that opposes any change in its state. If it is undergoing uniform rotation, then this moment of inertia is going to oppose if you want to change this state. If you want to change this state, then this is the property that is going to oppose that change. It opposes that change. Now, how it is coming into the picture, how can you observe? Suppose you are having an object, like this, for example, and it is rotating about this axis. It is rotating about that axis. I consider one of the particle here, and its mass is m1, and draw a perpendicular from here to here. So this will be r1. This will be r1. Now, when it is going to rotate, this particle is going to rotate like this. And this type of rotation you are going to observe for this particle. Okay, this particle is going to rotate like this. What will be its kinetic energy? Kinetic energy of this particle dk, this will be m1, and this will be half, and this will be v square, or you can say v1 square. v1 square. Okay. Now what will be v1 here? What will be v1 when it is undergoing? V will be equal to r omega. So it will be 1 by 2 m1. This will be r1 and this will be omega. And square of this, so this will be dk. This will be dk. So this will be 1 by 2 m1 r1 square, and this will be omega square. Here, in case of rotational motion, if you are having a rigid body, then try to understand each and every particle, it is going to have same angular velocity. ठीक है ना, it is going to have same angular velocity. If this object is rotating about this axis, then angular velocity will be same. However, velocity will be different here because velocity v will be equal to omega cross r. ठीक है, this will be omega cross r. So velocity is going to change, velocity will be different, but ठीक है ना, velocity will be different here, but this will be same. This will be same. Omega will be same for each and every particle for this rigid body that is rotating about this. About this, it will be like this. So this omega is same. Now this is the kinetic energy. This is the kinetic energy of this particle. If you consider the complete object, then you are going to consider this kinetic energy of all the particles, that will be dk, and I can write 1 by 2 out, and this will be sigma. In place of 1, I am writing here I, and this will be mi ri square, and this will be omega square. Omega square. So this will be total kinetic energy, rotational kinetic energy. It will be 1 by 2. And this property, this is called as moment of inertia. So this will be equal to I, and this will be omega square. If you compare this formula of rotational kinetic energy with the translational kinetic energy, then you will find out that formula is 1 by 2 mv square. So in rotational motion, this omega is corresponding to v, this I is corresponding to m. So whatever role is played by the m, by the mass in translational motion, same role is played by the moment of inertia. So mass is opposing any change in translational motion. Okay. Similarly, this moment of inertia, that is a property that opposes, due to which the opposition is there if you want to change the state of rotational motion. So that is moment of inertia. So you can write here first the definition of moment of inertia. Please write, likhiye. It is the property of a body. It is the property of a body. It is the property of a body due to which it is the property of a body due to which it opposes it opposes it opposes any change it opposes any change in its state of rest, any change in its state of rest or uniform rotation or uniform rotation or uniform rotation. So here, if you are having this axis of rotation, one object is this is a mass particle, it is rotating like this. It is like this, and this is R1. What is this? This is R1, mass is M1. It is rotating like this. Then moment of inertia of this system I, it will be कितना होगा बेटा? This will be M1 R1 square. This will be the moment of inertia. But if this system is having two mass particles which are moving, which are rotating about the same axis of rotation with the same angular velocity, omega is same. Suppose you are having another particle at a distance R1. It is rotating with the same angular velocity about the same axis. Suppose this is another object, M2. M2 is here. It is rotating about the same axis at a distance R2. Suppose this distance is R2 here, R2. Then what will the moment of inertia of the system? That will be plus M2 R2 square. If you are having a third particle here, third particle is, suppose it is rotating like this, and this distance is R3. R3, this is M3. then this will be plus m3 r3 square, and it will be like this. So what will be the total moment of inertia of all the particle? You can write like sigma I, this will be mi ri square. This will be the moment of inertia for a system of particles which are rotating with the same angular velocity around the same axis. So if you are having more than one particle and each and every particle is rotating about the same axis with the same angular velocity, then this will be the moment of inertia. This will be the moment of inertia. Now, suppose in place of discrete particles, here I'm talking about discrete particles, but suppose in place of discrete particles, we are having an object like this and it is rotating about this axis. This is a continuous mass distribution object. So this is an arbitrary body I am choosing here. Continuous distribution of mass is there. Then what you are going to do, you will consider a mass element here. Mass element, this is dm. Suppose this dm is at a distance r from the axis of rotation. It is rotating like this. It is rotating like this. So same thing I am telling you here. If you look at this body, if this object is rotating about this axis of rotation, then try to understand each and every particle. Each and every particle, they are going to have the same angular velocity. Omega will be same for each and every particle. Because together, this as a rigid body, it is rotating around this axis. So each and every particle, it is at a fixed distance from each other. Separation between two particles is constant. So when one particle is moving with omega, automatically other is also moving with omega. But their transverse velocity, tangential velocities, they will be different because they are depending upon the radial distance of the particle. ठीक है ना? This perpendicular distance from this axis r, it also depends upon that. So v actually depending upon r. So velocity v, ठीक है, tangential velocity, that is going to be different, ठीक है, for each and every particle depending upon how much far that particle is from the axis of rotation, or it is close to the axis of rotation, depending upon that, but omega will be same. So v will be different for different particles, but omega will be same. Omega is going to be same. So here in this case, if you are having a continuous distribution, continuous mass distribution, continuous mass distribution, distribution, then what will be this? What will the moment of inertia of this element? That will be dm and r square. So you can write it as r square dm. This will be the moment of inertia of this element di. Di. What will be the moment of inertia of this rigid body? Complete rigid body. You are going to integrate it over the rigid body. So this will be I. So moment of inertia of this rigid body about this axis, it will be given by r square dm. R is, so for continuous mass distribution, if you want to find out the moment of inertia, like for disk, okay, for disk, for cylinder, for sphere, then you are going to use this formula. You will use this formula. So for moment of inertia calculation, I'm going to use this I formula, or simple mr square. For example, one more thing is there. Suppose this is a disk. This is a disk, and this disk is rotating about this axis. This disk is rotating, mass is m, and its radius, I'm saying this radius is r. So this disk is rotating about this axis. I call it as, suppose, z cap axis. It is rotating about z cap axis, that is passing through its center. Okay, that is passing through its center. So what will be the moment of inertia? I will explain you how to find out, but most of you know it. This will be 1/2 mr square. It will be 1 by 2 mr square. So many particles are there and they are continuously distributed. Now you can convert this into a equivalent with the help of a concept that is called as radius of gyration. So one more concept is here that is called as radius of gyration. Here mass is m, radius is r, and you are having continuous mass distribution. If you look at it, is made up of infinite number of mass particles which are distributed like this. So I can make the equivalent of this. What will be the equivalent? Equivalent will be, I will equate it with this system. So what I'm saying, axis of rotation is same. This is the same axis of rotation, Z. And I will say that in place of this disk, a single mass particle whose mass is equal to the mass of the disk, it is rotating. It is rotating. Suppose at a distance k, from the axis of rotation, mass of this particle is equal to the mass of the disk. This axis and this axis are same, and I am saying they are equivalent system. They will be equivalent rotating system if its moment of inertia, what will be its moment of inertia? That will be mass mk square. So they will be equivalent if their moment of inertia are equal. If their moment of inertia are equal. So for equivalent rotating systems, for equivalent rotating systems, rotating systems, their moment of inertia should be equal. It means this mk square, it should be equal to 1 by 2 mr square. Mr square. So m will cancel out here, and what will be k here? K will be r upon root 2. So if I choose this k equal to r upon root 2, then moment of inertia of this system will become 1 by 2 mr square. So this rotating system and this rotating system, they are equal. They are equivalent, not equal, but they are equivalent. Whatever will be the moment of inertia of this, you have converted this moment of inertia problem into a single particle rotating problem, okay, where mass of this particle is same as the mass of this rotating object or rigid body, but this distance k, ठीक है ना, you are going to calculate this by equating, ठीक है, this mk square equal to moment of inertia of the rigid body. So k will be equal to square root of I by m. And what you call it? You call it radius of gyration. Radius of gyration. Gyration. This radius of gyration is a very important concept. Okay, this radius of gyration is a very important concept because you can always create a rotating system whose moment of inertia will be equal to this. ठीक है ना? If you are having this type of rotating system, you can convert into a single particle rotating system, and moment of inertia of both will be same. Later on, it will be very useful when we are solving the numericals. ठीक है? If you remove one part from this disk and you want to find out the moment of inertia of the rest of the plate, you can easily use this concept of radius of gyration, and very easily you can solve the problem. So this is a very important concept, and significance of this radius of gyration is that in place of rigid body, ठीक है ना, you will replace that rigid body by a single particle of same mass, but at a distance from the axis of rotation that is called as radius of gyration. So this is another aspect. This is another aspect. ठीक है? Is it clear to everyone up to this point? Hello?
Yes, sir.
Okay. So basically, moment of inertia is playing the same role as mass does in case of translational motion. It is opposing any change in the rotation. Now, next question was, what is the expression of moment of inertia? It is mr square for a single particle. If more than one particle, discrete particles are rotating with the same angular velocity, then it will be sigma. Okay? And I have given you this formula. This sigma mi ri square. Okay? And if you are having a continuous mass distribution, then moment of inertia will be given by this formula. Now, again come back. Now, suppose you are having a ring. You are having a ring like this, ring. And now, what is the mass of this ring? That is capital M. That is capital M. And now, suppose this ring is rotating about this axis. This ring is rotating about this axis. This is the axis of rotation. Mass is M, radius is R. Radius is R. So what will be the moment of inertia of this ring rotating about this axis, Z axis? Z axis. So what can you consider? You can assume that this ring is made up of large number of discrete particles like this. You can say it is made up of large number of discrete particles. Each particle is at the same distance from the axis of rotation. You can draw perpendicular on the axis of rotation. So this is our orbital. So, and each and every particle, they are rotating this complete rigid body, this complete ring, it is rotating with an angular velocity omega. 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 So every particle is at the same distance. So what will be the moment of inertia? Moment of inertia, it will be sigma. Sigma. ठीक है, कितना होगा? This will be first particle. Rather than sigma, I should write first like this. It will be first particle. I am choosing m1. Distance is r square. Distance will be r. For each and every particle, distance from the axis of rotation is r. For the second particle, it will be m2. And this will be r square. And you can consider infinite number of particles like this. Infinite number. So if I convert it into sigma, then it will be mi, sigma mi, and this r square is common. Sigma mi, what is the mass of the complete ring? Because each and every particle of the ring is at a distance r from the center here, from this center O. So automatically this sum of mass, it will be equal to the mass of the ring, and it will be mr square. So for the ring, moment of inertia will be mr square. It will be mr square. That is okay. ठीक है ना? This is okay. Next thing in your mind will be, suppose here that is okay, but suppose this disk you want to rotate, not this ring, sorry. We are dealing with the ring. Suppose we are rotating this ring about this axis. This is a axis like this. This is center of the ring, and it is rotating about this axis like this. Then what will be the moment of inertia? What will be the moment of inertia? Yes, beta, please.
Perpendicular axis theorem.
हाँ बेटा, ठीक है. Another question in your mind may be that if you are rotating this ring about this axis, then what will be the moment of inertia? If you are rotating like this, what will be the moment of inertia? Here, what will be the moment of inertia? This is my objective. I want to find out moment of inertia in this situation and in this situation. ठीक है. Similar case may be for the disk. If I look at the disk, this is the ring. If I look at the disk, This is a disk of radius r having mass m. This is a circular disk, ठीक है? And it is rotating about this axis. What will be its moment of inertia? How to find out its moment of inertia? That is very simple. What you are going to consider, you will consider a radial, you will consider a circular strip. Infinitesimal circular strip you are going to consider. So here you are considering a strip whose thickness or width is dx. So I'm considering this type of strip. ठीक है? At a distance x from here, radius of this ring is r. So at a distance x, I have considered this type of ring. This will be a ring very similar to ring structure. This will be very similar to the ring. It will be. I want to find out moment of inertia about this z-axis. Z-axis. Now, why I am considering this infinitely thin? I am considering it as infinitely thin so that I can assume that each particle which is present over this strip, that is at the same distance x from the center. This dx is very, very small. This is infinitely small. So what is the advantage of choosing infinitely small is you are saying that each and every particle which is present on this strip, that is at a distance x. That is at a distance x from the center. ठीक है ना, from the center. So what will be the moment of inertia of this strip? कितना होगा बेटा? That will be di. This will be x square multiplied by mass. This is mx square. So here m is dm and this will be x square. What will be this dm? Suppose mass of this ring, mass of this disk is m, radius is r. ठीक है? So what will be sigma? Mass per unit area, surface mass density. This is surface mass density. So total mass, mass per unit area. What you call it? You call it as mass per unit area. Mass per unit area. ठीक है? Total mass divided by what will be the area of the disk? Area of disk will be pi r
2 pi
square.
x dx.
No, 2 pi. This sigma will be m upon pi r square. So this is mass per unit area. ठीक है? Now what will be this dm? What will this dm? तो dm कितना हो जाएगा बेटा? This will be x square. What is the area of this strip? This will be 2 pi x into dx. What is the circumference? Circumference is 2 pi x. 2 pi x. 2 pi x is the length of this strip. You can say 2 pi x is the circumference of this circular strip. You can say it is the length of the strip. And what is the width of the strip? That is dx. So you can write dx here. Dx here. This is the area multiplied by the rho. That is mass per unit area. First, I write the area of this strip, that is 2 pi x dx into rho. Rho is known to you. So in place of rho, I am writing m upon pi r square. So here, this 2 pi is a constant. In place of rho, I can write m upon pi r square. Pi r square. Integrate, this will be x cube into dx. And this will be di. So this is the moment of inertia, ठीक है ना, of this strip. What will be the total moment of inertia about this axis? So integrate it. So you are going to integrate it. This 0 to r. X is going to vary from 0 to r. Here x is 0. At the outer point, it will be r, capital R. ठीक है? So this will be I, moment of inertia of the disk. This pi is going to cancel out. So this will be 2m upon r square. And this will be r to the power 4 upon 4. So I will be 1 by 2 mr square. This will be the moment of inertia of the disk. ठीक है ना?
Yes.
This will be the moment of inertia of the disk. Is it clear what I am saying? Yes, beta, please.
Yes, sir.
Good. Now, I want to show you something else also here in case of disk. This disk is made up of, try to understand, this disk is made up of two parts. ठीक है? ये जो disk है, you are rotating this disk about this axis. This is axis of rotation, Z axis. But you can consider that this disk is made up of two half disks. Two half disks. ठीक है? तो एक पार्ट ये है बेटा डिस्क का, that is rotating about the same axis. Another part is this one. And another part is this. This is another part. This is made up of two parts. Now, can you tell me what will be the moment of inertia of the half disk? ठीक है ना? About the same axis. This is first part. I say this is second part of the disk, second half. First half and second half. Can you tell me what will be the moment of inertia of this part one about this axis?
mr
Or
square by 4.
By 4
mr
स्क्वायर ही
mr
रहेगा.
square. हाँ, try to understand one thing, that you can use here the concept of radius of gyration. Try to understand if you are rotating this part or this part. If you are rotating this part or this part, ठीक है? Moment of inertia of both part about this axis will remain same. दोनों पार्ट का मोमेंट ऑफ इनर्शिया सेम रहेगा बेटा. ठीक है ना? दोनों पार्ट का मोमेंट ऑफ इनर्शिया सेम रहेगा. सो व्हाट आई एम सेइंग, moment of inertia of the complete disk is how much? This is 1 by 2 mr square. What will be the mass of this part? Mass of this part will be m by 2. Mass of this part will be m by 2. M by 2. So I can write this 1 by 2 m by 2 m by 2 plus m by 2 r square. So it will be simply 1 by 2 into m by 2 r square. You are saying correct, 1 by 4 m r square, but intentionally I am writing like this, 1 by 2 m by 2 r square. R square. So what will the moment of inertia of this? Because they are identical. Because they are identical, they are rotating about the same axis. So whatever will be the moment of inertia of this part, same moment of inertia will be for this. तो उसके लिए भी इतना ही होगा बेटा. Try to understand. So this will be the moment of inertia of one part. This is the moment of inertia of another part. So it's not changing. Formula is same. 1 by 2 for the half disk, formula is not changed. 1 by 2 mass of the half disk into r square. This is for first half. So now suppose I remove this half. Now suppose I remove this half. So what you have find out here, you have find out this. What do you have find out here? You have find out this. Suppose this is the disk, half disk, and it is rotating about this axis. And suppose now I'm saying its mass is m. Its mass is m. So what will, and radius is r. This is r, this is r. So what will the moment of inertia of this half disk when it is rotating about the axis? So its moment of inertia I will be 1 by 2 mass of the half disk. Now this is m and this will be r square. So formula is not changing. If axis of rotation is same, Either it is full disk or it is half disk. Formula is same. It is still m 1 by 2 mr square. But what is the difference? In earlier case, capital M was the mass of the complete disk. Now in this case, m is the mass of the half disk. This will be. Okay, this will be. So this will be why it is. Why in both cases you are having same formula. आपको same formula क्यों मिल रहा है बेटा? Can you tell me why you are getting same formula? Because try to
Symmetry.
understand if has due to symmetry, try to understand why you're getting same formula. Because if you rotate this, try to assume that it is rotating. On rotating, what it is creating, it is creating a symmetrical structure. That is a disk. Try to understand on rotating, it is creating a symmetrical structure. That is a disk. So whatever formula, so actually formula will be corresponding to the figure that is created after rotation. So on rotation, it is creating a symmetrical structure that will be look like a disk. जैसे फैन चलता है आपका, so चलते हुए फैन को देखो, a a plate type of a structure will be created. Similarly, here if you are rotating it about this axis, you are going to have a disk. So that's why formula here that is of a disk, but here mass will be of this half disk. So that's why formula is not changing. ठीक है? Now if I further cut it into two parts, so it was a circle like this. It was a circular structure like this. If you cut it into four equal parts, okay, what I do, I convert it into four equal parts. Means like this, quarter of plate. Try to understand. One part is this, another part is this, one part is this, and another part is here. So these are four. You have divided this disk into four parts. You have divided this disk into four parts. You want to find out the moment of inertia of the one part. This is part one. This is part two. This is part three. They are symmetrical and their situation is symmetrical. So what I'm going to do, I will divide this mass into four equal parts. So what you are going to do here, you will divide this into four parts. So this will be 1 by 2, 4 times m by 4. M by 4, M by 4. You have divided this mass into four symmetrical parts. You have divided this disk into four symmetrical parts. So what will be the moment of inertia of the one part? That will be 1 by 2 mass of the quarter of plate into r square. Plus for second it will be 1 by 2. Why they are equal? Because they are symmetrical. Why I'm saying this would be they are equal? Because they are symmetrical. This will be m by 4 r square plus 1 by 2 m by 4 r square. It is like this. So what is the formula for the moment of inertia of the quarter plate? The formula is same if you look at. So here if you are having this type of quarter of plate, just 1 second. Yes, Britta, please. Yes.
Sir, the last slide can you show?
Okay, but abhi, just 1 second. So this is quarter of plate. It is rotating. I will just show you, please. Just wait for 1 minute. So here it is here. It is rotating. This is quarter of plate like this. Okay. And this disk is rotating about this axis with omega. Omega is suppose angular velocity. Mass of this is m. Radius is r here. Radius is r. So it is like this. This quarter of plate, it is rotating about this. It will be, what will be the moment of inertia of this quarter of plate about this axis, z axis? Again, same formula. You're going to have I equal to 1/2 mass of this plate, ठीक है ना, into r square. But this time this m will be mass of this quarter plate. So try to understand why you are getting the same formula, because on rotating this quarter of plate about this axis, you are going to create on rotation. During rotation, you will observe a symmetrical structure disk. So formula is for disk. This is the formula of disk. Mass is only for this quarter of plate. So because on rotation, it is creating a symmetrical structure disk. That's why its formula is very similar to the disk. तो इसीलिए इसका formula जो है वो disk का formula है बेटा, ठीक है. So this is one thing. You can choose, it's not quarter of plate, you can choose any of the plate. You can choose any of the plate like this. You can choose any smallest part of the plate. It may be like this. And if you rotate this part about this axis, whatever this angle is, ठीक है ना, I don't care, this is alpha, but its mass is m, radius is r, suppose, then moment of inertia will be 1/2. This will be mr square. ठीक है ना, it can be any angle, it can be 10 degree, 15 degree, 20 degree, 30 degree, formula is going to be same. So this is another aspect. Next, as I have discussed earlier in case of ring, if suppose this is my disk and I want to find out the moment of inertia about this axis, I am rotating this about it. Then on rotation, what type of structure I am going to have? I will have a symmetrical structure. And if you are rotating this about this axis, you are rotating it about this axis. This axis, you are having a two-dimensional structure, two-dimensional planar structure, disk. So you will have some moment of inertia, but if you are rotating it about this axis along the diagonal, then you are creating a three-dimensional structure, sphere. So formula will not be for a sphere. So what I said you, that formula will be corresponding to the plate, that will be for two-dimensional structure. Here, mass distribution throughout its motion, it will be two-dimensional. So here, this is a two-dimensional structure. So if it is creating two-dimensional structure, then same formula will be applicable. But I want to tell you here that if you are rotating this disk, about this axis, then you should have a different moment of inertia. This should be different. If this is I1, it will be I2. Why? Because on rotating, you are getting a sphere. This is a different symmetrical structure. And here you are getting two-dimensional structure disk. Here, on rotating about this, you are getting a different symmetrical structure. So automatically this I2 will be different. I want to find out this I2. I also want to find out what will the moment of inertia about this axis. This may be a question. If I want to rotate about this, what will be the moment of inertia? So to find out these moment of inertia, these other moment of inertias, ठीक है ना? Basically, two theorems are there. ठीक है? So to find out other moment of inertia, as I have discussed, you have to understand two theorems. ठीक है ना? Two theorems. One theorem is called as, first theorem is called as theorem of principal axis theorem. Or not principal, sorry, parallel axis theorem. First is parallel axis theorem. And second is called as, second को क्या बोलते हैं बेटा? Perpendicular axis theorem. So two theorems are here for moment of inertia. First is called as parallel axis theorem and another is perpendicular axis theorem. So first is, what is parallel axis theorem? Okay, I am showing you. First I will show you, then I will give you the statement. Suppose this is a disk. I'm sorry, disk के बजाय मुझे लेना चाहिए, I'm taking a rod. Suppose this is a road. Rather than disk, I'm using road. That will be more simpler. Where will be its center? Center will be here, center of mass. It will be at center. This is a uniform road of mass m and length is L. Mass m and length L. What is this point? This is center of mass. This is center of mass of this. Now if you rotate this road about this axis, if you rotate this road about this axis, omega, okay? If you rotate this about this axis omega, then what will be the moment of inertia? Moment of inertia क्या होगा rotation से? I will calculate later on. This will be 1/12 ml square. It comes out to be 1/2 ml square. So this axis which is passing through the center of mass of the object, we will represent that moment of inertia by IC. So IC is the moment of inertia of this road about an axis that is passing through its center and perpendicular to its length. This axis is perpendicular to its length and passing through the center of the road. So this is IC. How much it is? This is 1/12 ml square. This is okay. Okay. Now what is the role of parallel axis theorem? For parallel, with the help of parallel axis theorem, suppose I'm having this. I create another axis. I have created a new axis that is parallel to the axis passing through the center. So this is another axis that is passing through one of its end and parallel to this axis that is passing through the center. So then dono parallel hona chahiye. So out of these two axes for which you are going to apply parallel axis theorem, one of the axes will pass through the center of mass. It is must. Whenever you are applying this parallel axis theorem, one of the axes will pass through the center of mass of the object. So one axis will be this. Second axis can be anywhere and parallel to this. Suppose that axis is here. So now question is, what will be the moment of inertia about this? If you are rotating this road about its end, it is rotating like this. What will be the moment of inertia? I want to find out this. This is I. So what is the formula? What this parallel axis theorem says? It says that this moment of inertia about this parallel axis parallel axis, it will be I equal to, this will be IC. IC is the moment of inertia of the object, ठीक है ना, about an axis that is passing through center of mass. So this is IC plus mass of the road and perpendicular distance between these two axes. Suppose this is X, so this will be mx square. So what is X? X is the perpendicular distance between these two axes. What is X? X is the perpendicular distance between the two axes. Okay? So this is the formula that is given by parallel axis theorem. What is important here? One thing is this IC. Don't write this formula correctly always. Always remember this one point, that IC will be here. You cannot write IC here. If I is known to you, suppose I is known to me, then I cannot find out IC. I cannot write like this. IC cannot be written as I plus mx square. You cannot write like this. This is a wrong formula. Remember this here. Here it will be the moment of inertia about an axis that is passing through the center of mass. X is the perpendicular distance between them. For example, here in case of road, this distance X, it will be L/2. So IC, I have given you, this is ml square by 12. 12 plus mass of the road is m, and X, this is L/2 in this case. So this will be L/2 square. So this will be ml square by 4 plus ml square by 12. You will find out this will be 1/3 ml square. So about this axis, I will be 1/3 ml square.
1/4
So
ml square.
this is called, क्या बेटा?
1/4 ml
1
square
by
आएगा ना वो?
कहाँ पे बेटा? कहाँ पर आएगा? 1/3 तो आएगा। देखो ये क्या है, ml स्क्वायर बाई 4, ये होगा ना बेटा 1/12 प्लस 1/4। ठीक है, सो 3 + 1 that will be 4/12,
Got it.
so this will be 1/3। ठीक है ना, 1/3, so this will be 1/3 ml square. So about this axis, this I will be 1/3 ml square, ml square. So this parallel axis theorem, it can be applicable in any case. Remember this, this is always applicable. 1D case, 2D case, 3D case, in all the cases, this is applicable. So this theorem is applicable for every case, either 1D, 2D, 3D. So first you can write parallel axis theorem is applicable. Parallel axis theorem is applicable for 1D case like this. For 1D case, comma 2D cases like disk, or 3D cases, three-dimensional cases like sphere or something. Parallel axis theorem is applicable for all the cases 1D, 2D or 3D cases. It is applicable everywhere. 1D case, 2D case, 3D cases. Now you can write its definition here. First, write the definition of parallel axis theorem. Please write. लिखिए. The moment of inertia of a body. The moment of inertia of a body about a given axis. The moment of inertia of a body about a given axis, like this, about a given axis, I, capital I, about a given axis I is equal to moment of inertia of the body is equal to moment of inertia of the body sorry, of the body about an axis parallel to the given axis, about an axis parallel to the given axis, and passing through the center of mass of the body, plus mx square plus mx square plus mx square plus mx square, where x is the perpendicular distance between the parallel axes. Where x is the perpendicular distance between the parallel axes. Now I am saying you that calculate the moment of inertia about this axis. Suppose here a massless rod, I attach this rod with a massless rod. This is a massless rod. Okay? And I'm rotating this complete system made up of this massless rod and this rod. Okay? About this. Okay? About this axis. And this distance is, suppose I call it as x1. And here moment of inertia is I2. So now you are rotating this rod. This is a massless rod. From here A to B, this is a massless rod. And from B to कुछ भी C तो मैंने use किया. So I'm using some another name. I'm saying this is P, this is Q, and this is L, suppose QL. Okay, this is. Now, what will the moment of inertia of this rod about this axis? I2 I want to find out. What will be I2? So you cannot do this. Try to understand. You cannot write it that this will be I plus mx1 square. So I2 is not equal to I plus, I write it as I1. Okay, I'm writing it as I1 here. This is I1. So I2 will not be equal to I1 plus this m. This is x1 square. So this is wrong. Remember this. This will be wrong. Here, at this position, you have to choose this moment of inertia about an axis that is passing through the center. So here, this IC will be required. So if you want to find out this I2, you are going to use this I2 will be equal to IC only, plus mass m and perpendicular distance between this axis and this axis. This is x plus x1. So this will be mx plus x1, and this will be whole square. So this will be the moment of inertia. So this is the way we are going to use this parallel axis theorem for calculating moment of inertia. For calculating moment of inertia. This is first theorem. This is called as
Sir,
parallel axis theorem. This theorem is applicable for all the cases. Yes, beta, please.
if
बोलिए.
in place of massless body PQ, we replace it by some mass, then position of the center of mass will change, right?
Yes, then you will consider two type of particles. In that case, you are going to use the concept of कौन सा concept use करोगे? बोलो. Either you are going to use the radius of gyration concept, or in another way you can also find out. In that case, what you are going to do, try to understand. What I will do, suppose this is a mass. It is also going to have a mass. Okay? So I call this a center of mass will be C1, and in this case, this will be C2. C2. So I will be aware about this smaller rod. I will be aware about its center of moment of inertia about this axis passing through C2. Then I will apply the parallel axis theorem for this smaller rod. And I will apply separately parallel axis theorem for this. It is like this. I'm just telling you on the next page. His question is, suppose you are having two rods. Like this. Mass of this is m1. Mass of this is m2. And you are rotating this rod about this axis. ठीक है ना? What will be the moment of inertia? कुछ डिस्टेंसेस दे देते हैं. सपोज यहाँ से यहाँ तक जो डिस्टेंस है, आई कॉल इट एज x1. और ये जो डिस्टेंस है, सो कुछ लेंथ ले लेते हैं. आई एज्यूम दैट दिस इज 2x1, saying 2x1 is its length, and I'm saying this is 2x2. This is its length. So these are the lengths of these two rods, and you have to find out moment of inertia if you rotate this combined system together about this axis. This is your question. So what will be the moment of inertia? I will be equal to moment of inertia I1 for this first rod about this axis, and for the second rod I2. What will be I1? Moment of inertia of this first rod about this axis. So what will be IC? This will be IC1. IC1. What will be IC1 for this? I call it as IC1. Plus mass of this rod will be M1. What will the separation between these two axes is? That will be X1. So this will be M1 X1 square. This will be the moment of inertia of this first rod about the given axis. It is like this. Okay? For the second one, what will be its moment of inertia about its center of mass for this? That will be IC2. You call it as IC2. This will be IC1. What will be IC2? I will calculate it. Plus mass of this is M2. And what is the perpendicular axis theorem? This will be how much? This will be 2x1 plus x2. So this will be into 2x1 plus x2 whole square. This is 2x1 from here to here. This is x2. So 2x1 plus x2 whole square. This will be. What will be IC1? IC1 का value कितना होगा? That will be m. What is the length of this? ml square by 12. So this will be m. Length is 2x1 square upon 12. This will be IC1. For the second road, what will be IC2? That will be m. What is the length of this? That is 2x2 whole square upon 12. So in this way, you can calculate. Okay? In this way, you are calculating. Is it clear what I have done? If you are having this type
Yes,
of
sir.
composite system, this is called as composite road. If you are having this type of composite road, by applying parallel axis theorem, you can find out the moment of inertia about this axis I. Okay, about this axis I. So these things will be more clear to you as more and more we are going to apply. I hope after the next class, after the second class, you will be very clear about this part of moment of inertia. So this was just a starting. Okay. This was just an introduction. I just want to introduce you how we are going to move forward. In the next class, these things, parallel axis theorem, perpendicular axis theorem, they will be more clear when we are going to apply these axis theorems to different cases. I don't believe in doing a lot of calculation in this part, but we are going to create a symmetrical system. What we will try a symmetrical system, and from that symmetrical system we will try to apply the formulas. Okay? So whatever cases are known to us, from those cases we will try to find out the moment of inertia in different cases. ठीक है, चलिए बेटा, थैंक यू वेरी मच. नेक्स्ट क्लास में मिलते हैं.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
वेलकम बेटा.